Good
Good
afternoon.
afternoon.
Good afternoon once again, and welcome to the webinar Belden presents Accelerating the Digital Transformation in Chemical Manufacturing, powered by Pro MFG Media. My own introduction, I am Manish Kulkarni. I am from Pro MFG Media, and we are a publishing media and consulting company focused on manufacturing industry. Belden is our very regular partner to bring such knowledge sharing initiatives for across the different sectors of the manufacturing industry. This today's webinar is focused on chemical manufacturing, and Indian chemical manufacturing sector is poised very interestingly. As we know that the chemicals, specialty chemicals, agrochemicals, or the different derivatives of chemicals touch our lives uh, in many ways. And it is an integral part of our daily life. This the chemical manufacturing industry currently is valued in India. The market size is about $250 billion, and it is expected to touch 1 trillion by 2040. So in next 15 years, there is going to be a huge fourfold increase. And there are reasons for that. One is, of course, the focus on PLI, the production linked incentive scheme by government, the demand drivers of consumer products, the FMCG products, the agri inputs. These are all the construction demand for construction chemical because of the infrastructure development. So all these actually are demand drivers for increase in the size of the industry. Having said that, chemical manufacturing is highly energy intensive, highly capital intensive, highly asset intensive business. It requires high amount of reliability and throughput from the assets deployed. And also, some of the most important factors are safety and sustainability. We have a great panel of speakers, esteemed speakers with us, which I'll introduce in some time to share their experiences, their best practices, the challenges and opportunities in chemical manufacturing, and how digital technologies are impacting chemical manufacturing and how it is likely to shape up in foreseeable future. We have, for the benefit of audience, thank you for joining. We have towards the end of the webinar, two activities. One is, of course, we'll ask you a poll question. So please answer that. So stay back till the end. And also, we are going to announce lucky draw winners, those who remain till the end from the audience. I request you, all of you, to be there till the end and be a part of chance to win lucky draw contest prizes. Some exciting prizes are to be won. The first thing after my welcome remarks is, of course, a presentation by a Belden representative. So I would request Gaurav Shanbag, who is a solution consultant manager, and Gaurav is focused on energy and process automation verticals within Belden. So I would request Gaurav to please take the proceedings and share his insights through his presentation, and then we'll jump into the panel discussion. Over to Gaurav.
Yeah, thanks, Manishi, and welcome to everyone who have joined this online, and thank you for all gathering the time. Uh, my name is Gaurav Shanbag, and I am a solution consulting manager for energy and process vertical. And today we are going to talk more about how we can accelerate digital transformation, like in chemical manufacturing. Uh, and these are of course, all the gentlemen and ladies who have joined are all experts in their own organizations and the fields, and we can connect later on more broader topics. But the challenges that we face, I think will all resonate with that. As a major challenge in the chemical industry, we see a lot of legacy systems, traditionally, which are into the system, in the manufacturing since a long time. Older automation systems are there. There are no common language. Data security, as more and more exchange of machine to machine communication is happening. Data security, IT, OT integration happening. Data security plays a very important role. At the same time, increasing capacity needs, you have capital constraints to execute projects in certain budgets. There are labor challenges, competency challenges, and of course, we have to be at mark with the technology and adopt newer technologies. And that is what is the race to modernize the infrastructure. Now, everybody knows about building a digital factory, and there are associated challenges with it. So it can be something to do with the labor shortages or the skill gaps that have to be filled up. So technology has to be easy to operate and easy to understand, easy to be adopted. At the same time, have increased efficiency levels. There are siloed networks in terms of OT and IT. There are processes which are siloed, and there are multiple reasons for it. Like and it is still sometimes a bit challenging to bridge multiple processes with each other for several reasons. Although someone may want that to happen. Operational reliability with challenging environments. There can be data which are very critical and which can not go down due to events like cyber attacks or equipment failures. So operational reliability is very important. Unsecured networks in terms of threats, that can be a intentional or an unintentional kind of attack that may happen to that may affect your production setup. And managing obsolescence. Legacy networks or legacy devices must always be migrated to modern, but then while that is done, it has to be done in a seamless way. So these are primarily the challenges that you face. While automation is mandatory to adopt for meeting multiple, the capacity needs and all, and operators experience has to be seamless. The key needs that we see is availability, the speed at which the data has to be used, and reached to make sure that the data is used in an efficient way. Unifying the data so that everything is brought on a common platform, so that there is more seamless communication and seamless integration of multiple technologies and multiple processes. Edge operation, data which is on the field in the has to be closely processed and has to be used for various use cases, and security at the same time, when like more and more vertical integration. So IT/OT integration is imminent. And at the same time, edge computing plays an important role because a lot of data is right there on the field. Convergence, where it comes to the future of data convergence, network and data has to be converged. So when it comes to field, there are people, there are assets and machines and sensors, which are basically, having the basis of all the, digital use cases that has to be implemented. And ultimately, everything has to be connected. Everything is talking to each other. Maybe contextualized data, which is getting exchanged with each other for achieving specific use cases is very important. And data solutions that can be easy to adopt in terms of meeting various use cases, which will come into which we'll discuss on the coming slides. So bridging all the data sources, having the connectivity between them, having the complete digital infrastructure that can be adopted for local computing or edge computing or cloud computing. Yeah, and all the applications that are on the IT side that has to maybe monitor or manage, give insights for where the budget should be transferring, for specific goals. Yeah. So all of that is something which is becoming a key need in chemical industry. And to adopt these things, it is not a tear apart and build a new one. It has to be something where it has to be the use cases have to be implemented in a very meticulous way. Yeah. So it has to be something that there has to be an understanding level while doing assessments. It can be workflow based assessments, or network assessment, or wireless assessment, or it can be process assessment. Designing in terms of consulting with the right people for who are domain experts, conducting testing POCs on a dry patch, and then making sure that it can be cascaded and replicated across multiple other other processes. Implementing it with proper project management and timelines, and at the same time upscale your skilled the labor by having continuous education, training, SLA, and technical support. Yeah. So this is typically an architecture, what you see as a converged one, where you have various processors, various field devices which are getting integrated, and these field devices can be from multiple automation players. These are these are needed to be, and when it comes on the common platform, they are all segregated, but at the same time integrated with the backbone network. There can be certain applications where wireless becomes an important part, for deterministic communication that happens between, the remote IOs, or, the drives, or, PLCs, DCS systems. So all these are something which are communicating continuously in a deterministic way. And the use cases have to be aligned, have to be met with by having these, this infrastructure. So there can be edge computing devices which are now starting to sit on the field, which has to be rugged in a way that can be sustainable for a longer time, which can collect the sensor data and send it directly to the cloud, with certain analytics and contextualization already built in. Of course, there are multiple components of application. It can be the network management system, or the remote SCADA system, or the anomaly detection part, which has to read the data which is on the field for complete visibility, for asset visibility, for process visibility. Yeah. And to a certain extent, even control, whether it is on-prem control or whether it is a remote control. So all of that, all these are components which are getting built into a digital factory or a connected factory. And the approach that has to be taken is something that we encourage to happen from OT to IT, because it is not just you or any organization on their own, but a complete ecosystem which builds into digital manufacturing. So those are OEMs, those are system integrators, of course the manufacturing owners, and of course OEMs as well. OEMs as in the people who are manufacturing the individual equipments as well. Yeah. So all of this is, an approach where a field to management or the sensor to cloud approach is taken from OT to IT, and not really feasible when it goes from IT to OT. So how to strengthen your mission critical priorities is, when you take care of future scalability, when you take care of redundancy in terms of, increasing your uptime by having highest availability of your assets, doing smooth migration from legacy to Ethernet based or packet based communication with lower latency and improved bandwidth, and quality of service in terms of precision timing, like where where the deterministic protocols, like it is real-time communication, where delays and drops are not tolerated. Like that's the infrastructure that anyone would want to build in. Digital use cases, basically when customers have adopted digital use cases, they have observed that there have been very notable improvement in productivity, in lessening the downtime in machines, in increasing the labor productivity by having more better people to machine engagement, and boost in throughputs. Yeah, so that basically is how you construct the use cases with smart IoT devices and adopting data models and digital twins on the OT side. And at the same time, in the IT side, it is how you build on, a common topic can be the security layer for OT and IT, and there can be, adoption of cloud and AI, ML, data analytics that is primarily from the IT or rather the manufacturing IT. Yeah. So various use cases can be used for can be implemented in chemical industry. Some of these are populated on the screen. You can see something like predictive maintenance or production schedule optimization. Real-time quality monitoring is something that we see on a very regular basis. Batch tracing and most importantly, to meet the sustainability and regulatory compliances. Yeah. While all of this is happening, cybersecurity is an important role. So this is again something where we are elaborating on how these different pain points can be met. The most importantly, the safety concerns in chemical industry, how to reduce downtimes, to reduce to tackle reduced throughput, increase our throughput, tackle low yield and quality. So all of these are something which are there are digital use cases to build. And while these are a broader digital use cases, there can be more in-depth digital use cases which can be adopted. So very broadly, we can say about for predictive maintenance, for predicting failure movements from the equipment of the equipments, like to see parameters, how when a particular equipment can get failed due to multiple reasons, due to wear and tear, or due to any like how as per the age the process or the machine can get old, and there can be some replacement that has to be taken place. Batch tracing is very important, where labeling and tracking your batches of product, when there is a quality lapse, or it can happen to any organization. If there is any recall, then there has to be a proper batch tracing. Yeah, quality monitoring is something that we have worked with closely with many customers, where quality of the product has to be monitored for enhancing the end customer experience of what the final product is going to be. Like it can be for a adhesive manufacturing, or it can be any other use case, and application which requires chemical uh, consistency. So how we are complementing various use cases, we built into the elements of remote condition monitoring and control. How the key benefits built in these use cases, like there can be cost savings that can prevent costly equipment from failures, and which can minimize the manual intervention. Yeah. So when operations which are critical and there is some failure, sometimes it may be required for having a remote access to the plants across multiple sites. One thing is, we can monitor you have to monitor the live parameters, and at the same time you may have to do some parameter changes and all. So that is something which needs to be implemented in a secure way, where you are having a remote access platform which is tracked, which is authenticated, which is encrypted. Yeah. And at the same time, you are able to do a condition monitoring in a very process oriented way. There can be multiple parameters or multiple technology components that can come into picture here. There can be remote access gateways. There can be protocol converters. There can be cables. Yeah. There can be edge gateways, multiple components that can come into this as a technology implementation. Another use case that we have seen very commonly, and we are playing a very important role in such applications, is the predictive maintenance by integrating or reading contextualized data from the IoT sensors. That's where there are multiple IoT sensors. It can be something to do with the humidity sensor, or the vibration sensors, or temperature sensors. So all of these data, can be contextualized, can be run through a algorithm through which there can be predictive maintenance, automation in terms of the how the device can be avoided from failures. Yeah, so that is again in not just predictive maintenance but also quality maintenance and quality monitoring of the end products that which becomes very critical. And again, here we have multiple components, again, like the IO-Link devices that can have integration of multiple industrial protocols converted to more open protocols like OPC or MQTT or REST API integration that has to be integrated with the edge or the cloud or the on-prem analytics platforms. It can be something where you have dashboards to monitor multiple quality parameters or the predictive maintenance parameters that are required for predictive maintenance. Yeah. And we as Belden are committed towards realizing the such use cases. We are everything that is bad there between the sources and destination, where we are able to bridge the gap between OT and IT, right from specialty cables, the data transmission, products, integrating it on a common platform, and having a common or a backbone with the data orchestration and for the visibility, the data management part, which can bridge the gap between the sources and destination, which can do all the control, monitoring, visualization, analytics, from the data that is received from sensors, motors, cameras, and machines. So that is what we do and where we play an important picture. Primarily, we are able to build solutions because of the various brands which are associated with Belden, or where Belden is building solutions out of these brands. So those are all the brands that you can see, and of course we can discuss on it separately. So that's all from my side today, and I would now
Thank you so much. Thank you, Gaurav, for that very comprehensive presentation, which set the context for this interaction with the panelist.
Yeah, thank you
I
so much.
loved on the first slide, you have that tagline of Belden, that is connect to what is possible. So wherever there is a connection, Belden is there in terms of data. You also touched upon important topics, which I will cover during my panel discussion. For the audience, if you have any questions, please post it in the Q&A box, and we will select those questions towards the end of the webinar. I now have the pleasure to welcome our panelists. I will introduce them, rather I'll announce their name and company name. And once I announce all the five of them, I'll request them to introduce themselves in 30 to 40 seconds, a quick introduction. So I'll announce the names not in any particular order. We have Kavishwar Kadambe from Crystal Crop Protection. We have Mr. Sridhara Narasimhan Sastry, who is from Grasim, Aditya Birla Group. We also have Chetan Joshi from Tata Chemicals. We have Bharat Kahate from BASF, and Subhash Singh Punjabi from Deepak Fertilizer and Chemical, and also Gaurav's colleagues Irwin Barneto from Belden. I would request Kavishwar to briefly introduce yourself. Kavishwar.
Hi, thanks, Manish, and it was a great presentation by Belden. I think amazed to see this all technology available. So myself, Kavishwar, I am heading technical manufacturing of crystal crop protection, chemical engineer, 25 years in the industry. So we look forward a great interaction with all of you. Thank you.
Thank you, Kavishwar. Sasri ji.
Yeah, thank you, Manish, and thank you all co-panelists. Shastri from Grasim Chemical Industries, currently heading a site, integrated chemical complex at Bibipuram, Andhra Pradesh. 38 years of experience in chemical manufacturing industry. And the user of OTs and ITs to the extent possible.
Wonderful. Mr. Chetan Joshi.
Yeah, thank you. Good evening, everyone. Thanks, Manish ji and Belden for inviting for this. I'm Chetan Joshi from Tata Chemicals, heading continuous improvement and digitization at Tata Chemical Mithapur. Thank you.
Great to have you. Bharat from BASF.
Hello everyone, all panelists and attendees. My name is Bharat Kahate. So I am from BSF Chemicals India Limited, operating out of Navi Mumbai. I'm a digitalization implementation lead for all Asia Pacific sites of BSF. So nice to be here and looking forward for an interesting session hereafter.
Thank you,
Thank you.
Bharat. Thank you so much. Subhash ji from Deepak Fertilizer.
Yeah, good evening everyone here, all the attendees and the co-panelists. So I'm Subhash Singh Punjabi working with Deepak Fertilizers. I've got around 3 decades of experience in IT and the all type of organizations like pharmaceutical, auto component, now in chemicals since from last 4 years. And I am handling here the enterprise architecture, security, and all the special projects for the smart factory. Thank you everyone. Looking forward.
Thank you, Subhash ji. And last but not the least, Irwin.
Yeah, hi, good evening to everyone. My name is Irvin Barneto. I look after the sales for the energy and process automation vertical at Belden. I also have a small amount of experience of 22 years in the digitization, telecom, and networking field. Happy to be here and to connect with everyone, the audience, and the panel. Yeah, looking forward to.
Thank you, Irwin. And it is indeed a pleasure to have this mix of panelists because you know what it has done is people on the panel are having diverse backgrounds. Collectively, we have some 180 plus human years of experience from chemical. And also on the operation side, on the solution side, on the IT side. So we have a great mix. When we heard the presentation by Gaurav, he touched upon the word IT/OT at least 6, 7 times during his presentation. And I was speaking with another leader recently, and he defined the digital transformation, DT equals IT plus OT plus CT, which is information technology, operation technology, and control technology. I thought that was a good definition. And here we have people handling all on the right side of the equation. We have experience here. So I'll start with Sasriji first. When we speak about chemical manufacturing and effectively implementing or integrating IT/OT systems to achieve the plant-wide visibility and faster decision making, could you share your experience, Asriji, and then I'll come to Subhashji.
Yeah, see, I come from Grasim Chemical Industries, from a chloralkali operation side. We have 8 chloralkali sites across India, pan India. So we were independently working before 2015 or 16. The idea came in for us to have how to integrate all the sites together through a platform. So we call ourselves as a central manufacturing cockpit. Today, all the OT technologies have been integrated with the help of IT. So I am sitting at, talking to you as I speak to you, I can see my operations at all 8 sites. That is only visibility of monitoring, not controlling aspects, as you know that. So the data from the operations, like DCS control systems, thousands of sensors, flow meters, and temperature controls are connected to DCS. All the 8 DCS are connected to a system background for the plant-wide visibility. Having said that, there are many other systems like ETP working, online analyzers. All of us know about the regulatory requirements. The CPCB is our requirement of connecting all the stacks to the servers of CPCB. So all these are connected through a platform for monitoring visibility of all sites, and that's an immense power it has. Though there is no control centrally, like I can't operate the plant at central level, but I can see all of them at location by pulling the data from these 4, 5 sources. One thing I still feel that we could have done further is the asset integration across all. When I say asset integration, about the data from the SAP like ERP, the DCS systems, and laboratory management systems, and most of the places we have moved from paper log sheets to e-log books. When I say e-log book, and it's also connected to the computers. So the data is available, plenty of data is there available. Though we are able to see the key process controls and safety, in the chemical industries, the utmost importance is of safety. We hear a lot about the safety incidents. The topmost priority is safety, of course, then the operational productivity and process optimization. So that still is a challenge. When we can do the asset integration, like key equipments like rectifiers, compressors, or certain aspects, if I can predict the life, is still we are doing at a manual level, integrating from different sources. If that can be done, I would say the IT/OT integration is will go to the next level.
Yeah, very well said. And for the benefit of everybody, uh, Sastri ji is very active on LinkedIn, and yeah, we need to have also know about his other side. So he has been posting very interesting lessons from Bhagavad Gita on LinkedIn. So
Oh,
it is good for professionals to actually study and follow Mr. Sastri on LinkedIn.
Thank you.
Subhashji, I will come to you about
yeah,
you come from a very diverse background of having worked in even in other sectors and largely in the IT. And here you handle the enterprise IT architecture plus as a CISO. It would great to have your views on this IT/OT integration piece.
yeah. Good, good. So I think Shastri has said various things here, which are very nicely mentioned, the things. But in my views, when we talk about how we can make this particular effectively integrating IT and OT, which is a thing. So here, for chemical manufacturing, effective IT OT integration isn't just a technology. It's a strategic move that enables real-time plant visibility, faster decision, and higher safety and optimizing. The same thing what Shastri has said, what he has done for his organization. So this is the crux when we will do. So now suppose we say the structurally we have to put this, how we can get all these things done. So first thing, I think the every organization want to do this the way we have done. So we have to have a clear integration strategy. What exactly we want? So define the business goal first. What because if we say about the digital transformation, it's a journey. It's not a small project. It's a multi-year project, and again we will reach to some level, and that goal post will get changed because some new thing will definitely come. So first thing is that we should have a proper business goal, a prioritization, what we have to do, what is the our asset utilization or reduced downtime, what exactly is our first priority. I think if we do that, that is the first part we should do. Another part, what I feel is that we should have a unified roadmap. Now, why we are saying unified roadmap? Because when we are talking and we are doing this for a shop floor, so there are multiple stakeholders. So we have to have a joint mapping with everyone, saying that with operations, maintenance, IT, cyber security, because we have already discussed, we have seen the presentation of Belden, and we have touched various time about cyber security also. So when we are doing something, this comes into immediately in our mind that how it is secured. Because earlier what we are saying that our control systems are totally in a, we can say the air gap systems are there. It's a control and nobody's, if you want to go there, a person goes, but there is no logical connectivity. But when we are saying digitalization, digital transformation, smart factory, industry 4.0, these are the synonyms. At that time, connectivity is must. So I think that we have to do. So I will talk about the high impact use case to be prioritized. Then I feel that we should secure the scalable network foundation, which is very important because, as I mentioned, when you do one thing, you will you have to have you will get something to know that we have to do something new thing also for that to get it, because this is like your analytics what we used to do. When people see something, they will demand for more. So we have to have a converged network architecture and how safe it is. Already in the presentation, Belden has shown the Purdue architecture, how we can keep that. Again, the most important part here, what I feel is the edge gateway. Because in the any chemical factory, we have to have something edge gateway there so that what's of connectivity, what's of data is coming up, how immediately we can see the result of it. There and there itself, the plant people should see something and not at the, it will go to somewhere and then it will come, it may waste the time. And one more point I think is very important, because in the chemical factory, there are multiple equipments, maybe, and multiple stakeholders of the OEMs. So time synchronization of data infrastructure is very important, because otherwise, whatsoever you will get, it can't get the correct decisions or results from that. So time synchronization is the one thing what we have to see. Then we talk about the IoT platforms. What platform need to check, so that need to select for us. Again, it depends. But then also, I think for chemical factory, then we can have one standard platform which you can utilize. Leverage real-time analytics. What I think Shastra has already touched upon that point. So real-time analysis that we have to leverage, how we can get that as one part I said about age. And the major thing where for chemical factory, what I have seen is that digital twin, which is very important because we can simulate the thing and we can understand if we do something, what will be, how it will work. So I think these are the some of the points what I want to put here in the interest of everyone here. Thank you.
Thank you. Thank you, Subhashji. This was, you touched upon also very important points such as the simulation of through digital twins to ensure safe and reliable operations, edge computing. Bharat, may I request you to please share your
Sure.
experience? Yeah.
Yes, yes. Thank you, Manish. Actually, you initiated a very valid point as a starting point for this discussion, which is about IT and OT integration. Yeah. So normally, what happened when we talk about any digital transformation, what comes in our mind is basically maybe it could be AI, ML, robotics, or cloud, or drone. Right? This kind of very high techy words comes into our mind, and that is very natural because that is the thing, something which we really see next to us every single day, right? But I will say this whatever we see is the result of the transformation, but it actually happens, or I will say this is the tip of that iceberg. The transformation begins much more before in the depth of that iceberg, and that is what exactly we are talking about. We call it OT system. So I always see OT as a shop floor and IT as a top floor of any organization architecture. So most of the data what is getting produced at the production level or at the OT level in every millisecond, right? Those data in the form of, let's say, various parameter, in the form of recipe, or your raw material consumption, or your finished good consumption record, right? So all these data what is producing is actually required for making some business decisions, right? So maybe I can give an example where your let's say supply chain or logistic, right? They want to know what is your raw material consumption is happening, or how much inventory you have in balance, so that they can maintain uninterrupted flow of your raw material available. So if our systems are working in silo and then there is no breach, it means that that brings the inefficiency into the system. And that is the place where integration between this OT system and IT system is very much necessary. So my view on the transformation or between IT OT integration is when our sensors will start talking to the cloud, and that's the place where real transformation will takes place. And of course the question is, how do we do that? Then of course there are a lot of ways to doing that, maybe by vertically integrating all our different levels of data and bringing them into the common platform. Like Shastriji also mentioned, he is able to see all his data by sitting, all the side data by sitting in his office, right? So that's also one way of doing. But of course, integration with the business level, like ERP system, is also much more important, and then later to the sending data to the cloud. So I think very interesting point where ITOT is I will say the basic foundation. So first is I always speak about the infrastructure part. When we achieve infrastructure, then of course the ITOT integration happens, and then the data visualizations takes place. So I think yes, it's very interesting point of ITOT integration. Thank you.
Yeah, Kavishwar, I'll come to you now. We heard from Bharat. Thanks for having that analogy of shop floor to top floor between OT and IT systems. In that connection, a quick comment from Kavishwar and Chetan Bhai also on how to make sure that Mr. Shastri mentioned about having a dashboard, visibility. We also heard Subhashji speaking about virtual twin, digital twin. Could you share your experience in terms of having the smooth data flow and leveraging that data for effective outcomes to improve your safety, reliability, productivity, quality? Kavishwar?
Yeah, thanks, Manisha. I think Bharat, Subhajji, Shastriji, they have mentioned it absolutely correct. Nowadays, I say these are the basics now, but unfortunately, still we are not, what you can say, we are not able to scale up at day one. So it is due to, we can say, I see from the shop floor to top floor, I always see that top floor always can come out with the investment. We have a concept and can get implemented. Whether the reliability of that system will be, getting guaranteed, still it's not there. So that's the hitch, I think. But if I see last 20 years of journey of it, when basically I can say I only see 20 years because I see that is how it has started at full fledged. Before that there was always a complex of it. I implemented first plant before 22 years. That was, I got that opportunity. So I see these are the basics. I see the how the industry can take it forward from, if anyone wanted to start it, the integration, having the correct reliable partner, that is one, and the strategy to move, not by the accident. So if we think that we wanted to go by accident, I'm sure you will go at certain level and then we'll see no. I really like the way Shastriji has explained. They have full fledged plan till the end, and he has also expressed his view. What he could not able to do it. So I think that's what the level of strategy we need. But these are the basics. So nowadays everybody want to have 100% reliable plant, because it's not only the domestic matter. We also cater to the export market. So from to have a reliability, the transparency and visibility is important. I see this integration can give the full fledged transparency and clarity to the people, along with the competency of shop floor. That's my take on it. Thank you.
Thank you so much, Chetan bhai. I would ask you slightly an additional follow-up question. What are the best practices that help chemical manufacturing companies to meet the stringent safety and compliance requirements using these technologies? If you can just expand on that, please.
Yeah, surely. I am audible?
Yes, you are.
So as Manish rightly mentioned, so in chemical industry now it become more and more complex, and it is a high risk kind of organization. So safety management and rigorous safety management and compliance management is very difficult, where digital tool can play a very critical role to transform the safety culture, streamline the compliance processes, and reduce various operational risk. Minimize the incidences, improve the safety standard and everything. So various kind of best practices, various organization uses typically. As first, I will start with some of the basic best practices. Normally, the organization have a centralized common EHS platform, where that EHS platform serve as a common platform which links with various function, various production, maintenance, quality function, and it uses a centralized platform where all kind of unsafe practices, unsafe behavior, near misses, incidences, with detailed root cause analysis, various audit, safety audit observation, corrective action, everything is mapped and it is available in a real-time basis. Additionally, this kind of platform can be leveraged with compliance tracking mechanism, where all kind of regulatory environment can be mapped, and it triggers the alert to the authorized people when before due date of the compliance, with the approved workflow and auto escalation. So it ensures that all compliances are addressed well in time, and it will also have digital trail of the complete system. And it also can leverage, this complete platform can be leveraged with all digital documentation, that is various SOPs, MSDS, that is material safety data sheet, emergency handling processes and practices. So all these things will be available at a click to the site people, so they can ensure all the safe work across the time. Similarly, digital work permit system. Work permit is a very critical element as far as safety is concerned. Traditional manual work permit system result in lot of productivity loss, and data tracing, tracking, and also data analysis also always been a challenge. So with the digital work permit system available, we can see at a time how many number of people are involved, how many quantum of work is going on, how many people involved, various lockout, tagout, everything can be visible on the real time basis. And with the set of various all data real time available, it can help us in data and analytics thing. So when we have all these digital tools available, this safety platform available, work permit system available, so with all this data, that is various safety data, there is unsafe condition, unsafe behavior, near misses, incidences, audit, corrective action, and all this, and permit data. With this and based on AI/ML algorithm, model can be built. It can predict also the where the any near miss or any fail, any incident is going to happen in future, any at any function. So with this, necessary corrective action can be taken at concerned department. It can safeguard the various people and equipment across the plant. Similarly, training and competency mapping competency is also one of critical element as far as safety is concerned. So based on AR and VR based technology, safety simulator can be available nowadays. Based on that, we can train the people on the high risk scenario, because that kind of scenario without any exposure also we can build on their skill and talent. And various safety kiosks and this kind of system is available, because when we want to onboard many contract workmen during any project execution and all these things, so safety training and all this, after we need to validate that training after their understanding and these things, so that can be validated easily through safety kiosks, and it can generally generate automatically safety passports also. Similarly, in chemical manufacturing section, plant emergency handling is also one of critical element. So every organization has defined various emergency scenario, various what are the key actions they need to take case of emergency with detailed diagram, detailed steps, with a detailed authorization, and all these things. So multiple time what happen when experienced people are aware of all this emergency handling scenario and tackling mechanism, but a new age people are might not be aware because that type of emergency has never come up. So with gen AI and that type of solution, by prompting various kind of question, one can easily identify what action one need to take in case of emergency and this thing. Similarly, in case of emergency handling and this thing, head counting is also very critical thing. Head counting at a company level and also at the assembly level and all these things. So in this case, there are head counting kind of system available which can be integrated with the attendance system, and thereby we can come to know okay, how many people are available at a time of emergency, and also if we have configured all emergency trained people in also our attendance system, then at the time of any emergency we can immediately come to know how many emergency trained people are available as of now in organization, so with their photo and contact details, so we can immediately take support from that thing, and it can help substantially in quickly addressing emergency handling situation. Similarly, uh, whereas PP compliance is also very critical in the organization. So with the help of digitization, we can have a video analytic or image analytic system through which we can real-time basis track the various PP compliance monitoring also. Traditionally, monitoring PPM compliance through maybe safety marshal or safety star is very challenging thing, and it lacks also productivity. So with the real time, this camera feed system and based on AI/ML algorithm, we can have a model which can find out the various violation as far as PP compliance is concerned in terms of helmet, shoes, or maybe jacket. Similarly, road safety is also very critical and vital element as far as chemical industry is concerned. So whereas there also based on AI ML algorithm, various model can be built and which can detect based on video recording and CCTV feed what are the various kind of road safety violation as far as overspeeding is there, safety belt is not used, maybe mobile using while driving, a zebra crossing by pedestrian in the wrong way, wrong parking, and blind spot detection. So all these type kind of system can substantially help in addressing the road safety kind of challenges. So safety have many challenges, and every challenge is possible through adoption of the digital tool and technique, and it can substantially transform the safety performance of any organization. Thank you.
Thank you, Chetan bhai. This was very well answered. So I'll come to Erwin. Erwin, as a domain expert, and Belden is having 120 plus years of experience across different domains. Specifically for this process industry, I wanted to know, we heard from all the panelists about the importance of flow of data. So that requires a connection.
Yep.
We also heard about the newest technologies like AI, ML getting used. So everywhere what is required is the fast, reliable data connectivity across different uh, uh, plant as well as shop floor, top floor. So how does Belden help, and what are your experiences in integration of this IT/OT for chemical manufacturing?
Yeah, Manish. Right. What everyone spoke, right? The entire panel really spoke on the core of the issue of IT/OT. And the experience of everyone over here shows, because people have come from a level where the digitization didn't exist in the plants to today, where everyone is attempting to digitize or has already gained some amount of progress in the digitization of their plants, right? And the panelists before me touched upon very critical points about the fundamentals of creating the infrastructure in the right way. Right? When we talk about IT and OT systems, where OT systems long time back used to be completely siloed, they used to be completely hardwired and driven by people, experts in their field operating on the shop floor. Today, OT and IT systems need to integrate, and we saw that in the pyramid that Gaurav also showcased in his presentation. Now, why we need to integrate the data is again what the people before me spoke about, right? It could be for very fast decision making, it could be for administrative purposes or pure regulatory compliance reasons that we need to send the OT data from the plant into IT systems. And when we talk about IT systems, we are not only talking about head-end applications that sit on the top of the architecture, we are also talking about IT users within the plant, right? We have OT users, we have IT users. And what we have seen our customers also doing is creating segregated networks within the plant for carrying services of IT and OT. And these have eventually a convergence point where the data eventually syncs and goes into further systems via DMZ. And this kind of integration is needed for the MES systems or sending data into SAP or any other monitoring purpose, like Mr. Shastri said, that they're able to see the data of multiple plants, but they cannot control. So it's not allowing you access within the plant, but you're taking a lot of data for decision making, right? And this data, again, is not only coming from automation sources like the PLCs, the HMIs, and the sensors, right? It's also coming today. Video analytics is picking up a lot. And just like Mr. Chetan said, that we need the data from cameras. We need this data to integrate with the OT data. We may need it not only to integrate for monitoring purpose, it can also be for control purposes, because video analytics is being used for a lot of quality control within various industries, like say even cement in steel, and a lot of industries are using the video analytical data for their quality control. So integrating all these kinds of endpoints is a challenge, and that is why creating a very robust IT network and a OT network that converges at certain point where the data can be sent to further head-end applications becomes very critical. And at the same time, you maintain the sanity of the OT network in terms of the reliability of the system, the availability of the system, and the security of the system, right? So these are the three fundamental things that you need when you're running a plant, so that there is no data loss, there is no data breach, right? And the uptime of the plant is also maintained. So these kind of robustness comes from a segregation of IT and OT networks as well.
Yeah. Well said. You mentioned about equipment availability, reliability, as well as safety. Mr. Sasri and Kavishwar, then I'll come to you after Mr. Sasri answers this question about the use of technology and the data for data-driven decision making. We've heard. How can predictive maintenance or these days even prescriptive maintenance and asset health monitoring reduce downtime, of course, increase your uptime and extend the equipment life? Mrs. Asri to go first.
You're on mute, Shastri sir.
Sorry, I was on mute. Okay, see, it's very, very important to use this prediction of equipments, life of equipments. So when we say about the technology of the process, we take into consideration the design of equipment, design of the process, safety data sheets, and the interaction of all the three with the people. That's a key aspect. So I would like to not use predictive maintenance very emphatically. I would like to use the word proactive maintenance. See, the question here is equipment has its operating designs and levels, and processes also we design in a way and we match both process and equipment. But what happens in real time, we have these market requirements, dynamic situations, we go a little bit up of the production, we increase the productivity by touching the limits of the both equipments as well as process designs. So I call them surges. And also we have in 24 by 7 plants where we see a lot of power failures, other related equipments. Suppose in integrated complex I make products, my product is used by adjacent ancillary units. So there are a lot of complex integrated scenarios are there here. So when the equipment, when my equipments are working, they are taking surges of either higher productivity or reaching the process designs for some reason or the other. Maybe raw material quality can impact, maybe higher, touching the bar of higher production can issue a problem, or some runaway reactions can also cause these things. So understanding these surges of equipments or processes and all, if that all these things and their interactions can predict the life of equipment, that gives a great sense. When I say that, say, suppose there is a life of 4 years, normally we give the 4 years of life, assuming that there are no surges. If you maintain the plant in a proper way through preventive, predictive, and proactive maintenance, when I say that controlling the process ranges, whenever there is an increase in either of these conditions of the process or parameters, I limit them. I probably limit my even production limits. If that is being done, and to some extent, as I said, the visibility of the plants, typically in a chlor-alkali industries, we have electrolyzers. Each electrolyzer has several elements or cells in that. If I take all my 8 sites, about 70 electrolyzers with each one having 120 elements, you can say that so many units are already working on that with so much of data and voltages, temperatures, all these things are being huge data. See, I said huge data where this prediction can happen to the life of my electrolyzer or the base metals or coating of these things. This to some extent is being achieved today, but if I have to really go to that level, as I said, how can I determine the life? I know there is a throughput for an equipment for 4 years, 1,000 tons or something like that. Probably in 3.5 years, I've already crossed that 1,000 tons. I'm aware of that. So it's not 4 year life, it's about how much throughput that comes. So taking into these two considerations, prediction of equipments and the process limits being exceeded, I will call it proactive maintenance. I think AI and all these tools should be able to really help us. What we have done is to optimize. I see cost is a very absolutely essential part. The voltage means higher the voltage means higher the power consumption, higher the power means higher the cost of manufacturing. So if I can optimize all these elements through this online real-time monitoring, which we are doing for this particular key equipment, it's a tremendous way of, even if I reduce one paisa or 1 kilowatt unit for all my sites, I would be saving about 1 crore per annum. So that would be the magnitude of that. So the day I can relate the prediction and proactive ways, plus one more thing I would also say about the transient modes of operations, that's a challenge for manufacturing industries. When I say transient, normal shutdowns, emergency shutdowns, and the startup and shutdowns and the safety aspects during these times. So the prediction of equipment during normal, during surges, during emergency shutdowns, and all this data available for all four different transient operational modes could be extremely useful. I think we are still a way to go on that.
Yeah, Mr. Sasri, very nicely said about moving from preventive to predictive to proactive maintenance. At this point, before I come to Kavishwar, I would request the audience, if you have any questions, please post it on the Q&A box, and as if time permits, we'll surely take some questions from the audience. Kavishwar, this moving from predictive to, or rather preventive to predictive to uh, prescriptive to proactive, now this is a new term which has come. Could you share your experience on how digital technologies are impacting this?
Yeah. This is very close to my heart because I really we did it, but I put it in a different way. Starting from either you say breakdown or immediate maintenance to preventive maintenance to predictive maintenance and predictive stuff deciding my preventive schedule plan. So that is how we have implemented in last organization. And there is a very classic case. You can take an example of one pump. I don't want to share the name of the company, but the company, due to not having the correct, you know, uh, we can say typically sensors on it, they have got a blast and they basically it's fortunate that they don't have got any loss of people, but they lost the production. And what they miss is only the one sensor which they miss. So, taking the clue from that, when we have started our journey, what we say, how we can basically improve our reliability of the equipments. So, in other way, it will improve my OEE, overall equipment efficiency, and lower my downtime, so that asset can be available always. And as Shastri was saying, there are multi-time people ask for the turnaround. How we can reduce the turnaround for that? Somewhere it's also statutory for some of the pressure equipment, but somewhere it's really not, where we can really improve the operational efficiency. So we have taken a sample equipment where we have a major breakdown. So I can say everybody, if, can understand the vacuum pumps. There are different type of pumps, and when you are into the continuous operations, you always observe either there are a lot of standby or there is a lot of consumables you spend it. So when we have taken this one, we have one partner. So we have put a very small sensor. So we have checked the pattern of it. Through pattern of it, we came to the conclusion that this is the best operating parameters, or whether these are the golden parameters, and these are the you know parameters which basically harm it. And as I was saying, from preventive predictive back to preventive, so based on that predictive input from the sensors, we have connected to the preventive maintenance. So we say by this time we will take for the PM, so that we can take care of that. So this has not only improved my upscaling of that equipment from 70% to the 95%, but also it has reduced my expense by 50% of the maintenance cost. You can say that 50% directly I could able to add it in the bottom line of the company. So that's the, what you can say, that's the potential, this IT/OT integration with keeping the correct strategy for the equipment, especially for the reliability of equipment it has. Thank you.
Yeah, thank you. Thank you, Kavishwar. Shifting gears, I'll come to Chetan Bhai. During your last answer, you comprehensively shared about how digital technologies are used to basically ensure safe operations. I'll come to another aspect of chemical manufacturing, which is highly energy intensive. So energy efficiency is so critical. Your specific energy consumption per unit of the product produces a very important parameter. So how these data insights are used for both ensuring energy efficient operations, and because it is part of driving sustainability goals. Could you please quickly share this?
Yeah, surely. So, as mentioned by you, sustainability is very critical nowadays for any organization. Due to enormous amount of environmental, regulatory, market, societal, stakeholder pressure is there, and now it is not a choice, but it is a strategic necessity as far as organization is concerned. So now for any organization to sustain, it require better resources, utility, waste, and all this thing optimization. It is very critical in the need of the time. with the digital technology available, it can help to monitor all the key sustainability KPI. Some of organizations have real-time visibility, some of have near real-time visibility. So more better is the you can have a real-time visibility. Once you have real-time visibility of all the sustainability KPI, you can set up alert and also advices for the corrective actions. So whereas sustainability KPIs are the total GHG emission of different scopes, environment compliance is the safety compliance, waste utilization. So all this, its key KPI can be monitored and controlled in the best possible real-time manner through various IoT-based sensor and various smart dashboard, and also alert can be set up and which help us in driving necessary corrective action also. See, as you mentioned that many utilities, as far as energy utility, if I take example of steam is a very vital utility as far as of power plant and various plant operation is concerned. So steam loss and wastage is critical issue at various sites. So nowadays, smart IoT sensor are also available, which steam trap monitoring. So in real time basis, you can monitor the steam trap health. That is, it is cool or hot steam trap is there, how much loss is happening, and it can be based on process data entered in that module. You can in real time basis you can see the how much financial impact it is having to organization on the real time basis. So based on that, organization can take corrective action also. Similarly, energy monitoring, energy management system is also available, where on real time basis you can see the energy consumption of various plant, various equipment, various device, segment wise, function wise, and it can be used as a compared with the benchmark performance of any plant and all this thing, and what are the energy losses happening on the real time basis you can monitor, and its financial impact can be real time visible, and necessary corrective action also can be taken up. When you have multiple this KPI on real time available, visibility is there, it can throw various predictive insight, and Gen AI and this kind of solution can be always use, which drives toward multiple kind of optimization action. So you need to carry out this action, you need to carry out this action. So it guides operator and plant team to optimize the various utilities. Similarly, when organization have very critical KPI, as you rightly mentioned earlier, where critical KPI is there, whether it is energy, water, resource utilization, optimization, there one can generate a digital process doing based on a prescriptive analytics. So where a real-time basis based on few years of data, prescriptive analytic model can be built, and wherever the output is there, output maybe energy, resource utilization is there, it can based on your input variation, it can throw light, it can throw light in terms of advisory to operator on real time basis, okay, how much deviation is happening. So golden batch efficiency level thresholding is done. So compared to golden batch, what is my current performance level, and if it is going down, due to what reason, it gives the real time basis prescription to the various operator, and he can take carry out required action. It prescribes also you need to do this much of correction, so he do this type of correction in DCS. And nowadays also it is possible to close loop. So there are semi-automatic code is also available, and closed loop is available, where this complete analytic system write directly into DCS system. It change the your set point. So totally autopilot kind of system is also available. So with this, wherever we have critical KPI based on prescriptive analytics modeling and this thing, one can substantially improve the energy efficiency level and address the sustainability goals of the various organization. Thank you.
Well said. Yeah, Chetan bhai, thank you so much. Sustainability, energy, and all the utilities management is so important. When we speak of digitally connected chemical factory or manufacturing plants, I will come to Bharat and Erwin both. What role does cybersecurity play in ensuring your secure operations? Because you have data, your cloud, you have devices which are connected to the outside world. So how does the cybersecurity and its role in ensuring secure operations? Bharat?
Yeah. So yes, cybersecurity plays very critical role when we talk about digitalization, transformation, or IT/OT. Yeah. So just imagine that when you have IT OT connected, we on means we all the panelists spoke what benefits it's bring to the table, right? But when your systems are connected, it also brings risk. So it is important to mitigate that risk, and for mitigation, we need to apply some specific measure. So when your systems are connected, whether it is internally, externally with the cloud or any other third-party system, it means that you are now more exposed. And especially in an industry like, for example, the chemical sector, any cyber risk, it can result into high level of environmental as well as physical damage. So just imagine a scenario that your critical OT system has been accessed by some external, and then he is able to play with some of your critical limits. So this could turn into disaster, right? So that's the reason the role of cyber security into OT, it's very important. So in order to achieve that, it is very important to follow some kind of structure approach to separate and segregate your different levels of architecture by putting firewalls, by applying some good defense in depth policies, prepare for your data backups, disaster recovery, and also do your good security assessment or secure integration assessment for whenever you're sending or connecting your system to cloud or any kind of generative AI models. Yeah. So yes, this is very important, and proper assessment and proper implementation. I think our colleagues from Belden has demonstrated a very nice picture in his presentation, how we should follow that structured approach from the level 1 to level 4 of IT/OT integration. And cybersecurity was also one of the topic he mentioned. So yes, that's very important topic. Thank you.
Yeah, you're right. Gaurav's presentation actually was highly insightful. I would request
Yeah.
Erwin to add your comments on this.
Yeah, Manish. So it is absolutely critical, right? We are digitizing, we're making data available to a lot of users, internal and external to the plant, and that is bound to add cybersecurity risks, to the integrity of your operations. So the data being made available to the external world also requires to ensure that there is a fair amount of protection. Like if you're monitoring data externally, no one else should be able to enter back into the plant and control parameters via that particular route. Right. So you implement things like data diodes that ensure unidirectional flow of traffic from the plant to an external monitoring system. When we talk about IT and OT systems, we talk about firewalls. Bharat mentioned about firewalls also. You have OT firewalls to protect your network on the OT protocols, and you have the IT firewalls to protect your network from the external internet-facing threats, right? So what studies show us is that within any plant, a lot of the cybersecurity threats happen internally more than externally, being attacked by, antisocial elements and so on. How do you protect from internal threats also is very important, because everyone has access to data now. It's no longer just legacy systems with legacy protocols that were not accessible to users. Anyone within the plant can access certain amount of data, and that can also add a fair amount of threat. So implementing systems like network access controls, right, that take care of internal cybersecurity threats also becomes important. So it is all up to the planning of the plant administrators to decide to what extent and to what part of the network they want to really protect, right? You have to protect internally, you have to protect the data that is going external to the plant, and you have to protect the threats that can come from external of the plant back into your operational network.
Okay. Thank you so much, Erwin. Since we are coming close to the time, and there are some very interesting comments and questions, they're both interesting observations. So we'll take them offline. We'll take it to the respective speakers who it is addressed to. I would now launch a poll for the audience to. There are three questions to this. So please answer these polls, and then I will announce the names of lucky draw winners as well before I propose vote of thanks. So here is the first question. The first question is about your feedback for the webinar, and there are three questions. Would you like Belden to contact you? The second question is about whatever we have discussed, does it align with your company's needs? So simple three questions. I'll wait for a few seconds more for responses to come in. And now I will have the pleasure of announcing the names of lucky draw winners. So let me go through the list first. At the back end, my colleagues have identified people, and I'll end the poll now. I'll just count 5 to 1, 5, 4, 3, 2, 1. I'll end the poll now. I hope you've been able to respond. Yes. So I will now announce the names of lucky draw winners. We have Manoj Malaviya from Lakshmi Organics. We have Nilesh Vitlani from Tata Chemicals. Then we have Inder Kumar from Henkel, Rahul Dev from Aarti Industries, and then we have Rajiv Raghavan from Grasim Karwar. Congratulations to all the lucky draw winners. Please keep a check on your email. You will receive the good news and the prize as well. So we have had great discussions. I mean, right from Gaurav's presentation till the end of this webinar, we had discussions on productivity, reliability, safety, sustainability, including cybersecurity. So we have touched upon all the important points for digital transformation of in chemical manufacturing. We will be posting the gist of discussions on our LinkedIn page. If we can have a thank you slide, yes, come up here. So on our LinkedIn page, we'll be posting the gist of discussions in the next few days' time. So please follow us on LinkedIn. This QR code, what is displayed, please scan it. It will go to the LinkedIn page of ProMFG Media. And just stay tuned for more such interesting knowledge sharing, both webinars as well as in-person sessions for across the manufacturing industry and across India. So please stay tuned. I thank Belden team for giving us this opportunity to partner. I thank all the audience for being participative. You asked very interesting questions and staying till the end. And most importantly, I thank all the panelists who took time out of their busy schedule to be here with us and spend this wonderful 1.5 hours. It was a pleasure for me to get connected. I wish you all a very happy, great evening, and also a happy Independence Day in advance. A long weekend is coming. Enjoy. Thank you so much.
Thank you. Bye.
Thank you.
Bye, everybody.
Thank you.
Thank
Bye.
you.
Bye-bye.
Thank you. Thank you.